Okay, good day everyone. Welcome to our session 3 of the subject Earth Science. Okay, so last time we have discussed about the different branches of Earth Science according to its sub-sciences. So again, we have the four sciences, the major aspects of Earth Science, the astronomy, meteorology, oceanography, and geology. So now we will tackle more about it. Okay, so let's go to another dimension and discover the realms of time and space as we fly back in time. So we would know about how our universe started from scratch. Okay, how it is originated and what are the different theories that talks about its origin and what will happen to it in the future. So you have watched the documentary um, is Genesis history. So mainly it talks about the two governing paradigms. Okay, one we have the conventional paradigm and the second one is we have the Genesis paradigm. Okay? So of these two paradigms, the conventional paradigm interprets everything according to the timeline and events that were constructed over the past 200 years. We have the Genesis paradigm, on the other hand, interprets everything in light of the timeline and events that were recorded in the first chapters of Genesis. So, the meaning of paradigm is uh, mainly the interpretation of history. So each of us has its own perspective on the aspect of what had happened in the past. Okay. So these two paradigms, or what we call interpretative frameworks, used to interpret the world around us. Okay. The conventional and the Genesis. So in the conventional, it tackles more about the science itself. In the Genesis paradigm, talks more about the biblical concepts. So each of these two has its own different views, okay, of how long the earth has been here. In the conventional paradigm, it talks about millions of years ago. In the Genesis, it talks about thousands of years ago. Okay? So mainly it includes, so the two includes the origin of rocks, the animals, and as well as the stars. So basically these two sees the same data, but the problem is, or the difference is, it interprets it according to different assumptions. Okay, so we have this conventional and Genesis paradigm. So the conflict is ultimately between these two competing histories of the world with respect of time itself, because in the Genesis paradigm, the universe is made by span of days only. But in the conventional paradigm, it was created in millions of years. So that's why the two of these paradigm are in conflict with each other. Okay, so let's go further, more about the conventional paradigm. So the science of the universe. Okay, so universe. So how do we define universe? So what is uh, the universe? So we have this. So the universe basically is the totality of space and time of the past, present, and the future. So overall, these are enormous collections of heavenly bodies from the smallest unit up until to the whole universe itself. Okay, so on the one hand, many things had to go just right for a universe to turn out the way it did and turn out how it is being developed. Okay, so we will start it from the story. Okay, so when we talk about the totality of space and time, we are talking about the structure of everything. So the structure of everything comes from the smallest unit up to the largest unit. So here are the things that is included in this structure of everything. So from quarks to the subatomic particles, we have the neutrons, protons, and electrons. And these subatomic particles consist of our atoms. And these atoms provides the molecules. Okay? And these molecules will create the matter itself. Okay? And these small, minute particles creates our planets, creates our solar system, creates star clusters and galaxies, and so on so forth until such the universe has been created because of this structure of everything. So for example, we have these following pictures here. So these are examples of galaxies. So we have this one, we have this Eagle Nebula. Next, we have this Lobster Claw Nebula. The third one, we have this Soul Nebula. And last but not the least, our own Milky Way galaxy. Okay, so all of these galaxies mentioned are governed by different forces. That's why it is intact, meaning it can be seen on its own specific position. Okay, because of these four fundamental forces. So without these forces, our universe cannot be the same as we see it from today. Okay, so we have these fundamental forces. So one, we have this gravity. So it is an attractive property of mass. Okay, light also responds into it. Also, gravity reshapes space and time and acts between objects and mass. So, for example, our own Earth has been subjected to the gravity of our sun. So, mainly it is revolving because of the gravity of the sun. Our moon also is subjected to the gravity of our Earth. So, that's why it is revolving around our Earth. Okay? Same as with our solar system or our own galaxy. It is revolving or it is moving on on its position itself. Okay? So, next fundamental force is we have electromagnetic force. So, when we talk about electromagnetic force in chemistry, it is the interaction of charged particles. So, it is responsible for all surface interactions of matter and it binds atoms together. So, without these atoms, um, there will be no shape. Okay, it will become chaotic. So these are the first two fundamental forces. The other two forces are the nuclear forces. We have this strong nuclear force and we have this weak nuclear force. So we have strong nuclear force. So in electromagnetic force, it binds atoms together. Okay. In the strong nuclear force, it holds and binds the protons and neutrons together in the nucleus of the atom. Okay, again, the electromagnetic force binds the whole atom, while the strong nuclear force binds the protons and neutrons in the nucleus of the atom. Okay, so on the other hand, we have the weak nuclear force. So it is responsible for nuclear radiation and fission. So mainly it is found in radioactive decay. Okay, from the parent isotope to the daughter isotopes. Okay, so all of these four forces governs the whole aspect of our universe. And without these forces, there will be no universe. Okay, there will be no us. Okay, there will be no creation. Everything will become um, chaotic in a manner of such that everything will have no shape. Okay? Walang wala talaga. Okay? As in zero, as in dark, as in black. Everything will become dark. Okay? So these fundamental forces affects the composition of our universe. Okay? So only about 4% of all the mass in our universe is composed of our own universe itself. Okay? So 4% are the atoms. We have the dark matter and dark energy. dark matter involves the 22%, and dark energy the 74% of the composition of the universe. Okay, now, what do we mean by dark matter and dark energy? Okay, fun fact, these two materials or components have not yet have not yet been detected in laboratories. Okay, but it is assumed that it is there. Okay, so we have this dark energy and dark matter. So dark matter refers to exotic matter that interacts only weakly with ordinary matter. Okay, so while no such matter has ever been directly observed, its existence has long been suspected. Okay, because there is always a somewhat lack of interaction with respect to the real matter itself, and the process of which is another form of a bizarre form of matter. We have this dark energy. Okay, so this dark energy is characterized by a large negative pressure of repelling force. So when we say repelling force, it includes, for example, I have two magnets here. Okay, if this one is pointing north, this one is pointing north also, the two of them will repel. Okay, meaning it cannot go further forward. Okay, so it makes that it will be repelled from these two materials. Okay, that is the repelling force, the dark energy. Okay, so those are the components of our universe. Okay, now we have these components and we have these origins. Okay, we have these theories underlying of the conventional paradigm, and it involves mainly of the theory of the Big Bang. Okay, before which we will discuss more the universes that were assumed by scientists in the past before we will tackle about uh, the Big Bang theory itself. So we have these types of universes. So we have this famous flat universe, we have this closed, we have this open, and we have this accelerating. So flat universe meaning the expansion of this universe slows down, but it never stops. So it will be continuously and gradually expanding, but on a slow pace. Closed universe, on the other hand, is when gravity eventually be stopped or be halted, and everything will go back to its original size. Okay, that is for the closed universe. We have this open universe. From the word open, it is continuously expanding on the same rate. Okay, and the expansion goes on forever. So we can do it in mathematics. So imagine that this is the object, it is expanding on a uh, times 2 scale. So times 2 times 2 times 2, that is the open universe. And lastly, we have this accelerating universe, and that involves the Big Bang theory itself. So this universe is an expansion on which the universe is speeding up or exponentially expanding. So in an open universe, the expansion will be on the same rate. In accelerating, it will expand exponentially. Okay, let's try to visualize these types of universes on the next image. Okay, we have this flat, close, and open. And the right one is the accelerating. So in the flat universe, we can see that it we can observe that it doesn't change, but it is expanding, but on a slow pace, on a slow rate. Closed universe, it will end. It at some point it will be become on its maximum scale, and it will shrink again. That's why it's called close. Okay. Open universe, it is expanding on the same rate. And accelerating, we have this big, vast, and exponentially expanding universe. And that is the Big Bang theory. Okay, so let's have a full discussion on the conventional paradigm that talks about the Big Bang Theory as its origin. So, what is really the Big Bang Theory? Okay, so on the image, so this theory explains the origin, okay, and suggests that the universe is part of an expanding system where all galaxies are moving farther away from each other. Okay, so as you can see, from the dawn of time, it started unknowingly. So we don't know yet how did the universe originated from scratch. Okay, but we all know that it continuously is expanding millions of years ago, and it will continue to expand in the future. So, question now is, who is the proponent of the Big Bang Theory? Okay, the one who came up with this Big Bang Theory on a science matter is actually a Belgian priest. Okay, so we have this famous Father George Lemuer. Okay, and according to him, the Big Bang Theory, in his own assumption, is that the universe blinked violently into existence 14 billion years ago. So it contends that the universe originated from a cosmic explosion that hurled matter in all directions in space. So the Big Bang is often described as an explosion, but imagining it as an enormous fireball isn't accurate because the term explosion there is actually the appearance of matter and space. There was no explosion in the first place. Okay? So the Big Bang involved of a sudden appearance and expansion of matter, energy, and space from a single point. And that single point is what we call the primordial ball. Okay. So it was proposed in the 1920s, and the framework of which relies on the model of Albert Einstein's general theory of relativity. Okay? And also its simplifying assumptions of homogeneity and isotropy of space. Okay. So, what happened on the Big Bang scale? So, let's have a timeline so that we can understand everything on it. So, we have this timeline. So at the start of the Big Bang, the universe was too hot and dense to be anything, okay? But a simple small particle, smaller than atom, okay? And that is what we call the primordial ball. And this primordial ball is composed of the first elements. We have the hydrogen and the helium and small traces of lithium and beryllium. Okay, because of the interaction of these elements, there was an explosion, quote unquote. Okay, the appearance of matter and space. Okay, and that explosion started everything. Okay, and then it inflated in such a way that in just a millisecond, it grew up into a massive size. So, for example, we have this small fist here of mine, and eventually it will become larger than Earth. That that had happened after the quote unquote explosion. Okay, so after that, the universe is expanding continuously. So the gases cooled down and condensed to form the stellar systems, or what we call the galaxies. Until such 20 billion years in the future, it will continually to expand, and we don't know yet if it will uh, go back to its original that will create another Big Bang, or it will continuously expand until such everything will be created and destroyed. Okay, so everything will have its constant change. Okay, so this is the timeline. So let's talk about it one by one and step by step. So we have this Big Bang Theory step by step version so that we can understand it more. So the first step is we have this in the beginning. Okay. So in the beginning, the Big Bang was not an explosion in space. Instead, it was the appearance of space everywhere in the universe from the primordial ball that comprises the first elements. Okay. After which, the second step is the growth spurt. Okay. So it underwent an incredible growth spurt. So during this burst of expansion, which is known as the inflation, the universe grew exponentially and doubled in size at most 90 times. So after the inflation, the universe continued to grow, okay, but a slower rate. So as the space of it expanded, the universe cooled and matter eventually is formed. Okay. And these new materials, the new matter for the first 380,000 years, the intense heat from the universe creation made it essentially too hot for light to shine. And this is the third step. Okay. So atoms crash together. Um, atoms and are interacting with each other. That is enough to that has enough force to break up into a dense opaque plasma of protons, neutrons, and electrons that's scattered like a fog. Okay, so everything is continuously interacting until such it the universe itself is expanding again. Okay, and throughout the gases cool down, and eventually the third step, the next step, we have the let there be light. So matter cooled enough for electrons to combine with nuclei to form neutral atoms. Okay, so this phase is what we also know as the recombination phase. So recombination meaning it is the absorption of the free electrons, okay, that causes the universe to become transparent. That's why light is being emitted on this portion. Okay, when light is being emitted, what will happen is, for example, I have these point sources of light. Okay, eventually it will be expanding the universe. Okay, the universe will be expanding, and these 2 point sources will um, go further away from each other. What will happen on this middle portion here? This is the next step. So we have these cosmic dark ages. So roughly 400 million years after the Big Bang, the universe began to come out of its dark ages. So this period is what we call the age of reionization. So clumps of gas collapsed to form the very first stars and galaxy. So as these are being created in this age of expansion, more and more stars and galaxies are being produced, and as well as the birth of new solar systems. From our own point star, we have our sun. We have also the governing planets that is revolving around it. Okay? And other heavenly objects that is found on the solar system itself. Okay. So, lastly, the universe will expand, and it is expanding exponentially. Thus, it is accelerating. Okay, now we can say that this Big Bang theory had happened because of such evidences. Because at this moment of time, we have the tools that are powerful enough to look deep into space. Thus, astronomers can detect light, okay, from the 375,000 years after the Big Bang. So this tells us that the Big Bang theory had happened in the history of our universe because of these evidences. Okay, we have these four evidence. So we have one, we have cosmic microwave background radiation. Number two, we have the composition of the universe. Three, you have the age of stars. And lastly, the main evidence, you have the redshift data. Okay, so let's go the go over with these evidences one by one. Okay, we have this cosmic microwave background radiation. As you can see from the image, it has different colors, and these different colors tells us the temperature and the heat that has been left over from the Big Bang itself. So this is exactly what we see when we look at the light from 375,000 years after the Big Bang. Okay, so this fog is referred to as the cosmic microwave background, or what we call the CMB, and it has been carefully mapped throughout the sky. So these temperature changes were actually evidences of the heat left over from the Big Bang. So we can say that the early universe should have been very hot. Okay, so this map displays the CMB as temperature variations of different translations to the density of matter itself. Okay, as a history, we have these different simulations. So in 1965, we have this radio transmitter that is made by Penzias and Wilson, but it is inaccurate compared to the latest. We have the WMAP and the Cove Explorer. Okay, or we have the COBE and we have the WMAP Explorers. Okay, so because of these technologies, we can know about the what had happened of the heat remains from the start of the Big Bang explosion. Next evidence is we have the composition of our universe. So as we all know, we have these elements that is very abundant in space because primarily for the Big Bang to be accurate, the simplest elements or the first elements would have been the first to form. So we have this hydrogen and helium. Okay, and all the heavier elements that would have come from nuclear fusion inside the stars. Okay, so as we all know, this matches the predictions made by the Big Bang itself. So in fact, the measurements show that the universe is 74% hydrogen and 24% helium. So in order to create this much helium from nuclear fusion, the universe should have been at least 12 billion years of age. Okay? So we have this third evidence. We have the stellar life cycle. So the age of stars. So as we all know, the universe cannot be younger than the oldest stars. So the stars form in different sizes. Okay. So usually from the collapse of a nebula or cloud of dust and gas in space. So the larger stars fuse hydrogen into helium at a tremendous rate. So the bigger the star is, the older it becomes. Okay. Until such there will become a time that the fuel um will be used up and it eventually will become a white dwarf. So the more the fuel will be exhausted, the more the age of the star itself. So when we say that if our own stars has its own life cycle, how much more our universe? So that is the assumption for that. Okay. So we have the last evidence. We have the redshift data. So we have this by Edwin Hubble. So Edwin Hubble is a scientist that justified George Slimware's theory through his observations that the universe is continuously expanding, meaning the galaxies are moving away from each other. Okay, because he has its own Hubble Space Telescope, and he observed that two heavenly bodies are moving away from each other. Thus, he has its own law, his Hubble's law, which stated that the rate at which a galaxy is moving is directly proportional to its distance from us. So basically, there will be no two galaxies that will go forward upon each other. It will be basically move away from each other. So by studying this, if you are the observer, as you can see a moving object from you, you will eventually see the red shift. Okay, the wavelength on which we see the red color. Okay, like for example, to have an analogy, we have traffic lights. Okay, so we have this red color that means to stop. So why is it that this red color symbolizes the stop? Okay, why not the green one? Why not the yellow one? Okay, it is because that the red color can be distinguished if uh, on the farthest distance. So we can see the red color on a far away distance from the observer and to the traffic light itself. Okay, so if you see an object that's moving from you, you will be eventually see the red wavelength. Okay, as a visualization, the universe is continuously expanding like this Rasengan here from Naruto. Okay, so overall, this redshift basically is the shift in the expanding wavelength of light towards the red color. So if you see a moving object away from you, you will see the wavelengths towards the red color. Okay, and this suggests that space itself is expanding, and that implies that some point in time the universe was smaller. So that was the assumption and the evidence of Edwin Hubble. Okay, the question now is, this one. So we have this visualization. So as you can see from these different clusters of nebula, the farther the distance, the closer of it to be seen in the towards the red wavelength or the red shift. Okay, so here we can see the changes in wavelength towards the red color of some galaxies that is being observed from the Earth as the distance is getting away or getting farther away. So we can uh, simulate it on these images. So that talks about the evidences. Okay, now the question which is that why is the Big Bang theory remains a theory? So what is the reason why? So actually, these evidences has its own limitations also. Okay, we have these four limitations of the Big Bang. Okay, one is we have this monopole or structure of the universe. So the Big Bang theory predicts the production of heavy, stable magnetic monopoles in such that there are no magnetic monopoles that have been observed. So meaning it makes no attempt to explain how structures like stars and galaxy came to exist. So we don't know yet how did these things originated from start. So that is one of the limitations. The next limitation is that we have the horizon or what we call the fluctuations in the CMB radiation. So from the images that we have discussed, the temperature of the CMB is observed to vary slightly across the sky. Meaning, based on the Big Bang, distant regions of space in opposite directions of the sky are so far apart and everything is fluctuating. So there is no exact point on which the Big Bang uh, had happened. Okay, on which at which point does it originated? We don't know yet if the place on which the exact position of the start of the Big Bang theory. The third one is we have the geometry of the universe or the flatness. So it was revealed that the geometry of the universe has to be nearly flat. Okay. However, the Big Bang theory should be curve as time grows because we all know that it is expanding in every direction. Okay, but we can observe that at our own observing point that the universe is flat, like we see in the horizon. Okay, as we go on the coastlines, we can see the horizon and not the real structure of the earth, same as with the universe itself. Lastly, we have the inflationary universe. Okay, the inflationary universe is still untested. Okay, meaning we should conduct more and more experiments to provide evidence for it. Okay, so these are the limitations on which the Big Bang remains a theory. So that is all for the session 3, and next meeting or in this session 4 we will talk more about the more underlying theories of the origin of the universe and as well as the origin of our solar system. Okay, so that's all for this session. See you on the next video.